Section 10.3 is on solving radical equations. For your learning target, you will be able to solve radical equations and you will be able to identify extraneous solutions. So jumping right into an example one, we're solving radical equations. And so we want to work on getting this radical by itself. So we're going to start by subtracting the 4 from both sides. So we're going to bring down the square root of x. The 4's cancel, and 9 minus 4 is 5. So now we need to get rid of the radical, the square root. And so to get rid of that square root, we're going to square both sides because a square root and a square cancel. So once you get the radical by itself, then you're going to square both sides. So the square root of x squared is x, and 5 squared is 25. So our answer here is 25. In the next problem, again, we want to get the square root by itself. So we're going to subtract 10 from both sides. So the 10's cancel, and we have negative square root of x is equal to negative 15. And then we want to move that negative. So I'm going to divide both sides by negative 1. So I have the square root of x is equal to positive 15. And now again, since we have the square root by itself, we're going to square both sides to cancel the square root. So again, the square root of x squared is going to give us x. And 15 squared is 225. So x equals 225 is our answer. Example 2 is still solving a radical equation, but this time we have multi-steps. So again, we're trying to get the radical by itself. So almost treat the radical if it was like an x, like we were solving just a regular linear equation. So we're going to start by adding the 1 to both sides. So I'm going to bring down 3 times the square root of x plus 5. These ones canceled, is equal to 12. Now, this 3 is being multiplied by this, so we're going to divide both sides by 3 to continue to get the square root by itself. So now we have the square root of x plus 5 is equal to 4. These 3's canceled. So now again, you have the square root by itself. So then we're going to square both sides because the square root and the square will cancel. So then we end up with x plus 5 is equal to 16. Then finally, we're going to subtract the 5 from both sides. So we end up getting x equals 11. So for our next one, example 3, we have a square root on both sides. So we're going to start by immediately squaring both sides to get rid of these square roots. So when I square both sides, the square root of both sides cancel. So we're left with 4x minus 3 is equal to x plus 9. And then we're going to solve this the same way we would a linear equation. So I'm going to subtract the x from both sides so I can gather my x's on the left side. 4x minus 1x is 3x. These x's cancel, equal 9. And then we're going to add the 3 to both sides. So we have 3x equals 12. And then lastly, divide by the 3 on both sides to get the x by itself. So we end up getting x equals 4. Example 4 is solving a radical equation involving a cube root. So this is kind of going back to what we did in example 1, but instead of squaring both sides, we're actually going to cube both sides. So my cube root is by itself. So I'm going to cube both sides because a cube root and a cube will cancel. So the cube root of 2x minus 5 cubed is going to give us 2x minus 5. And 3 cubed is 27. So we're going to solve this equation. So I'm going to start by adding the 5 to both sides. My 5's cancel. And then 27 plus 5 is 32. And then I'm going to divide both sides by 2 to get x equals 16. So example 5, we're going to start looking at extraneous solutions. And so an extraneous solution is something that you can solve for, but when you check it, it doesn't work out as a solution to the equation. So for this problem, we're going to start by squaring both sides to get rid of the square root. So on the left side, I'm going to have x squared. And then on the right side, we're going to have 20 minus x. So we want to move everything over to the left side. So that way this is equal to 0. So I'm going to go ahead and add my x over. So now I have x squared plus x equals 20. And then I'm going to subtract this 20 over, keeping this in standard form. So I have x squared plus x minus 20 equals 0. So now we want to factor our trinomial. So again, you're looking for numbers that multiply to negative 20 and add to 1. So the numbers that multiply to negative 20 and add to 1 are going to be positive 5 and negative 4. So that's going to give us factors of x plus 5 and x minus 4. So then we're going to use the zero product property, ZPP, and set both of these equal to 0 to solve for x. So I'm going to subtract 5. So we get x equals negative 5. And then I'm going to add 4. And we get x equals 4. So since we're working with extraneous solutions here, we do need to test this by plugging it back into the original equation. So if I plug this back into the original equation, I have negative 5 equals the square root of 20 minus negative 5. So that's going to become 20 plus 5. So 20 plus 5 is 25, and the square root of 25 is 5. So negative 5 is not equal to 5. So x equals negative 5 is an extraneous solution. Because we were able to solve for it, but when we tested it, it didn't work. So now if we try 4, we end up getting 20 minus 4, which is the square root of 16, and we do get 4 equals 4. So x equals 4 is a solution to this problem. Example 6, again, is working with extraneous solutions. So again, we're going to work on getting the radical by itself by subtracting the 7 from both sides. So I have the square root of 3n is equal to negative 6. So then again, to get rid of the square root, we're going to square both sides. So when we square both sides, we get 3n is equal to 36. So negative 6 squared gives you positive 36. And then the last step is to divide by 3. So we're going to get n is equal to 12. So now when we test this, we have 7 plus the square root of 3 times 12 equals 1. So 3 times 12 is 36. The square root of 36 is 6. And then 7 plus 6 gives us 13, which is not equal to 1. So for this problem, we have no solution.